Hello guys, today I'm going to talk about conservation of momentum. That's the following topic on your physics books, so I want you to go to page 205 so you can keep up with me. As you should know already, we have been talking about momentum. We already defined what momentum is. Just to refresh, momentum is the product, that means the multiplication of the velocity of an object times the mass of the object. So today we're going to talk about conservation of momentum. As you can see in the picture, we have one ball that is moving, which is ball A, and we have also a ball at rest, which is ball B. Ball A has a velocity, let's say 1 meter per second. So that means that the momentum of ball A is greater than 0. It has a momentum. While ball B has a velocity of 0 meters per second, which is at rest. So that means that the momentum of ball B is 0. Conservation of momentum says that, for example, ball A, which has a momentum, is going to collide. That means it's going to crash into ball B. After the collision, given that both balls have the same mass, all the momentum from ball A is going to be transferred to ball B, and that is what conservation of momentum means. The transference of momentum, that momentum is conserved, non-momentum is lost or gained. So the definition of momentum, of the conservation of momentum, would be that the momentum of ball A plus the momentum of ball B before the collision has to be equal to the momentum of ball A plus the momentum of ball B after the collision. And we summarize that in a simple mathematical equation. You know that P means momentum, so initial momentum A plus initial momentum B equals final momentum A plus final momentum B. So expressing momentums in terms of mass and velocity, we have this formula in which we're going to use lowercase v for the initial velocities and lowercase u for the final velocities. So as you can see, we have on purple, we have the initial momentum of object 1 plus the initial momentum of object 2 equals final momentum of object 1 plus final momentum of object 2. Another thing to mention is that momentum is conserved for objects pushing away from each other. As you can see, we have a spaceship which is not moving. That means that the momentum of the spaceship is 0. As soon as the object starts to gain momentum, that means it begins to move, it has to use combustion, it has to expel something in the opposite direction. That is the fuel of the spaceship. So now we have two objects moving in opposite directions. The spaceship that has a positive velocity, as you can see, the final velocity is identified by letter U. So the spaceship has a positive velocity to the right, and the gases that are propelling the spaceship have a negative velocity in the opposite direction. What conservation of momentum tells me is that both the initial and the final momentums of the spaceship and the gases have to be the same. They are conserved. So now I want you to pause the video and go to page 208 and find sample problem D, which is what we're going to solve right now. So problem D says, a 76 kilogram boulder initially at rest in a stationary 45 kilogram boat steps out of the boat and onto the dock. If the boulder moves out of the boat with a velocity of 2.5 meters per second to the right, what is the final velocity of the boat? So in the problem we have the data. The boater, the person who's riding the boat, is 76 kilograms. So let's say mass 1, 76 kilograms. Now it says that the weight of the boat is 45 kilograms. So we have mass 2 equals 45 kilograms. That's the mass of the boat. What is the initial velocity of the boat and the initial velocity of the boater? I want you to think about it. In the problem says initially at rest in a stationary boat. They're both at rest because the boater is in the boat. That means that if the boat is not moving, the boater is not moving also. So both velocities are 0 meters per second. Both initial velocities. Remember that we use v for initial velocity. Now, final velocities. The final velocity of the boater would be represented by u1. On the problem says is 2.5 meters per second to the right. Why do we take it positive? Because we assume that to the right of 0 is positive. And the problem is asking us to calculate the final velocity of the boat. Person moves to the right. In what direction is the boat going to move? Since this person needs to push the boat and momentum has to be conserved, that means that the person moves to the right in a positive direction and the boat is going to move to the left in a negative direction. And the sum of both velocities, of both momentums, has to be 0 because of the conservation of momentum. Since the initial momentum was 0, then the final momentum has to be 0. So now we have a formula for this. This is the previous formula about conservation of momentum. So what is the value that we need to calculate? We need to calculate the final velocity of the boat. So that means that we have to solve for this variable. Pause the video and try to solve it on your own. We don't have an initial momentum because what is the initial velocity of both the boater and the boat is 0. That means that velocity times mass and velocity times mass is going to give us 0 on both cases. So that means that the initial momentum is 0. Now it's easier for us to simplify and solve for u2. As you can see, we move this term, which is positive, we move it to the other side and it's going to go negative. And this m, the mass, which is dividing with the velocity, which is multiplying with the velocity, we're going to divide it on the other side. So now we have solved for u2. Now we have to input the data and let's see what answer we get. Please pause the video and try to do it on your own. We input our data, mass 1, 76 kilograms, velocity 1, initial velocity 1, 2.5 meters per second. It's positive because it's moving to the right. Divided by the mass of the boat. The mass of the boat is 45 kilograms. So after solving, we obtain this, negative 4.2 meters per second. What does the negative sign mean? That means that the boat is moving to the left. I want you to solve problem number 1 by yourselves. And I'm going to solve problem number 2 so you can understand another example. So let's go to problem number 2 on practice Z on page 209. Problem 2 says, an 85 kilogram fisherman jumps from a dock into a 135 kilogram rowboat at rest on the west side of the dock. If the velocity of the fisherman is 4.30 meters per second to the west as he leaves the dock, what is the final velocity of the fisherman and the boat? So the mass of the fisherman would be m1, 85 kilograms. The mass of the rowboat would be m2, 135 kilograms. The initial velocity of the fisherman, it says when he jumps from the dock, is 4.30 meters per second. Final velocity of the fisherman and final velocity of the boat. Once he's on the boat, what are these two final velocities? We apply the same formula for conservation of momentum, and we now solve for the final velocity. Since the fisherman is on the boat, they are traveling at the same velocity. So both final velocity of the fisherman and final velocity of the boat is the same. So that means that we can rearrange this way. As you can see, both final velocities are the same. So we can factorize, and after factorizing by taking out the final velocity as the common factor, we get this new formula. Now we have this, and we have to solve for final velocity. So it's simple, since u is multiplying with both masses, this goes dividing to the other side. Initial velocity 2 means the initial velocity of the boat. Since the initial velocity of the boat is 0, this goes away. It becomes 0. So now we only have this left. We divide this mass 1 plus mass 2, and we're left with this formula. Now we input the data and we obtain the final velocity of both objects. After inputting the data, you now solve and you're going to obtain the final velocity. Please pause the video and do it by yourselves. Now we have both the final velocity of the boat and the fisherman on top.